Good morning, all of you. In today's session, we are going to start with CSIR Net GRF Chemical Science, December 2014, Part C5. Earlier, we completed entire Part B in 3 different sessions, and even 2015, 2016, 2017, 2018, 2019, and 20 as well. All these question papers, detailed solved answers are available on the channel called World of Competitive Chemistry. Right, this kind of previous year question paper discussion will fetching you towards to analyze the question paper criticality and the weightage of individual chapters, and it will give you the perception towards the examination which you are writing for any entrance or competitive exam. If you are really aspirant about research, so in that case also it will be very much fetching for you. So let us enter into our today's concept. Today we are going to discuss about CSIR Net GRF Chemical Science, December 2014, Part C Series 5, consisting questions from 111 to 120. Let us go with question number 111. In the following reaction sequence, the structure of the product is. Here, the starting material is a fused molecule of 2 5-membered rings, and here you can find alpha beta unsaturated center, and here geminal dimethyl, here vicinal dimethyl groups are present within the molecule. They are treated with series of reagents. Hence, you can consider this question as a reagent chemistry. And the DIBAL H was added. 1.1 equivalent DIBAL H compound is added. H indicates what it is susceptible for reduction process and dissolved in the solvent called hexane, non-polar solvent being used for this purpose. Minus 78 degrees centigrade temperature will be employed. And here, chloro CH2COOH, alpha chloro acetic acid. This is called alpha chloro acetic acid, and the diethyl azo dicarboxylate PPH3 will be added, and these are this will be the catalyst for the reaction. Being it is a nucleophile, it will be added to the static material, and finally it's subjected to lithium aluminum hydride. Now let us see series of reactions carried in this and what will be the final product for this kind of reaction. For that purpose, first we have to know about few reagents which are mentioned in this. One is about DIBAL H. DIBAL H is denoted as a aluminum catalyst, where it is composed of bridged aluminum molecules, and these are the moieties which are called isopropyl CH2CH3. So this is said to be isopropyl group. Diisopropyl, each aluminum is arranged with the 2 isopropyl moieties, so that here it is the dimeric form will be appeared. Diisobutyl aluminum hydride will be taken in this DIBAL H, and it is very essential for the process of converting functional group transformation is possible, especially reduction reaction got carried by using these DIBAL catalysts. Let us see what could happen in this reaction. We are taking a fused ring structure with alpha beta unsaturated center, and it will be treated with DIBAL H. Consequently, whatever aldehyde is there, that will be added with this aluminum. So there is a possibility of oxygen aluminum linkage, and subsequently hydrogen got released as hydride, and it will be added and consequently turned into a hydroxy compound. Later, we are going to treat with this the reagent what they mentioned, that is diethyl azo dicarboxylate. Diethyl azo dicarboxylate. So diethyl aza means diethyl aza dicarboxylate compound was taken and is in contact with PPH3. Triphenyl phosphine will be added, being phosphorus pentavalent in nature. Here 3 bonds are there, more 2 electrons are free for donation, so that these electrons will participate in the bond formation, and the pi bond will polarized towards the nitrogen in either nitrogen atom. So here is the nitrogen phosphorus bond formation, and in either nitrogen is acquired with the negative charge. This negative charge will use to abstract the hydrogen which present on the given nucleophile called the alpha chloroacetic acid, so that hydrogen will be eliminated, and this turned into a carboxylate moiety. Carboxylate will be generated. Now we are going to treat this compound, that is diaza carboxylate with attached with a triphenyl phosphine, will be treated with the lone pair of electrons present in the oxygen of this condensed system. So being oxygen is associated with 2 lone pair of electrons, they are susceptible for the donation towards this electron deficient electrophilic center. So that here new bond is originated between oxygen and phosphorus. Here you can clearly observe oxygen phosphorus bond got generated and oxygen will acquire a positive charge. Subsequently, this entire moiety will be eliminated and ppH3 retained by oxygen. Oxygen is retaining ppH3 and the remaining entire moiety got eliminated in the form of diazo compound, whatever we used in the earlier step. So in the similar manner, it will be back regenerated. Now we got oxygen substituted ppH3 triphenyl phosphine, and being oxygen is associated with lone pair participate in the double bond formation, so that you can get allyde type of compound. Oxonium ion got generated. Now oxonium ion is said to be a electron deficient center, and there is a provision to attach the nucleophile which originated due to the pulling of hydrogen from the center. We got oxide in this step by the hydrogen abstracted by this diazo compound, so that carboxylate got generated. This carboxylate will bonded to the carbon of this bicyclic ring system, being it is a nucleophilic center. So here phosphine oxide got generated. So this ppH3 double bond O, phosphine oxide got eliminated as a byproduct, and this entire moiety will be attached. So already existing group is inclined towards a VR with the wedge bond. That's the reason why this negative charge will come from the back end only, right? So this is a kind of SN2 type of mechanism. So inversion, Walden inversion kind of stereochemistry will be employed, because already existing group is towards a VR. There is only the provision to attach this group from the back end, so that here the incoming nucleophile is indicated with the dotted line bond. This will be the stereochemistry, and subsequently it is added with the last reagent whatever provided within the problem, that is lithium aluminum hydride, so that here oxygen get in turn converted into hydroxy functional group. This will be the final compound what could be achieved in this reaction. So where bridged hydrogens are denoted with the dotted bonds, and even hydroxy also with dotted bond. What the reason? Because of SN2 kind of nucleophilic addition at this carbon center, so that we will get the oxygen with the dotted line bond. So the final product will be oxygen indicated with the dotted line bond, which is available only in the option number 2. So here methyl positions will not be varied, hydrogen position will not be varied, only we are reacting with the center. Hydroxy should be inclined away from the VR. Then in case of the third option also, you can find OH or dotted bond, and even methyl, because we are not going to touch even methyl group. So that's the reason why we are not supposed to change the stereochemistry of these to methyl. Only the suitable answer will be option number 2. For question number 111, option number 2 will be the right answer. Let us move on to question number 112. Here, the correct combination of the reactants and their rho values are. So here, the characteristic parameter rho value for the given organic reactions we have to correlate. For that purpose, we are taking aniline treated with benzoyl chloride. Aniline upon treating with benzoyl chloride, this is called a Sandmeyer reaction, and dissolved in the solvent called benzene. Then what is its rho value? Then let us see what will be the significance of rho value. Rho is the measure of susceptibility to influence the substituent groups. So what kind of groups present, and because of that, what will be the rate of reaction? That kind of equilibrium constant or rate constant can be directly predicted by the parameter called rho. The value is the measure of substituents influence on the rate of the reaction. That interrelation is provided by the parameter called rho. So when we are taking this, we can say this is a benzylation on the aniline. So because of this benzylation, what will be the rate of the reaction? That is called its rho value. Then when we are taking phenoxide, ARO minus is nothing but aryl group. If you consider it is a benzene, now you can say PHO minus, nothing but phenoxide. So when phenol eliminated with one hydrogen, that in turn converted into phenoxide and treated with ethyl iodide, simple reaction. What happens here? Iodo will be discarded and electrophilic center will be added here. You could achieve this ether group and dissolved in the ethanol. Then here we are taking ARCOOET. So this is a kind of system called ethyl benzoate or ethyl aryl oxalate. So this is the ester compound and treating with sodium hydroxide dissolved in ethanol. What will happen? base catalyzed hydrolysis got carried and the corresponding carboxylic acid and alcohol got generated. We have to predict their rate of reaction, nothing but rho values to be predicted. So let us go with the detailed discussion for all these combinations. In the first reaction, we are taking aniline treated with benzoyl chloride dissolved in benzene solvent, and its rho value for this reaction will be -2.69. It is the physical parameter which in turn correlate their rate of the reaction with the functional groups present in the given starting materials. So whenever these two got combined, this is chloride, this is the base. HCl condensation reaction got carried and the corresponding amide got generated. This will be the reaction number 1. Let us move on to second one, phenoxide. When phenoxide is treated with iodide will be discarded, ethyl will be added on the center in the presence of protic solvent called ethanol. Then rho value will be -0.99. So it converted into a ether compound. Then reaction 3, we are taking the ester treated with base alkali. Again, it is the condition provided is ethanol. Here it is having positive rho value with a +2.01, and the final compounds will be ester got hydrolyzed forming carboxylic acid called benzoic acid, and one more compound ethanol will be originated. These are the different reactions with different rho values which are provided. So this aniline benzoyl chloride -2.69, A with R provided in the option number 2 and 3. There are the probabilities for second and third options. And phenoxide treated with ethyl iodide, its value will be -0.99. The kind of electrophilic addition to the center, so that -0.99 will be provided only in the option number 2. And third one, ester hydrolysis under alkaline conditions, positive rho value that is available, CP, that is available in the option number 2 only. So A with R, B with Q, C with P, all are available only in the option number 2. For question number 112, option number 2 will be the right answer. Let us move on to question number 113. It is a part of organic spectral analysis process. The following reaction gives the product racemic, which exhibits the following NMR data. Proton NMR delta values are 2.67. For 2 hydrogens, it gives a singlet. 5.60, 2 hydrogens a singlet, ppm. Then C13 NMR delta values 170.3, 129.0, 105.0, 25.4 ppm. The structure of the product racemic is, what is the structure of product we have to predict? It is a kind of system called a cyclic lactone, right? So ketonic group and adjacent oxygen will be there. This is in the cyclic manner. The cyclic lactone with the, you can take this molecule, the cyclic heterocyclic ring with the pyrand moiety and adjacent carbonylic functional group is also present. You can simply say it is a lactone. Simply it is added with aqueous NaOH. When aqueous NaOH added, what happens? Ring opening, because so being lactone is very sensitive for alkaline conditions under drastic conditions, so that ring opening will be possible. So when ring opening, ester when subjected to alkaline hydrolysis, it correspondingly turned into a dicarboxylic acid moiety, and these two double bonds are there. They will participate in the ring cyclization, so that you can achieve a 3-membered ring structure. Then we have to predict which is the suitable form and what will give the correct spectral analysis. So we have to go with its spectral analysis here. Within the problem, proton NMR, C13 NMR data was provided. So if you go with option number 3, so in that here these are said to be vinylic hydrogens. Vinylic hydrogens 5.28 to 5.47 values are provided, and when the cyclopropene ring is attached with, so this OH will give the signal at 11.0, and another also having 11.0, and even this cyclopropyl having one more hydrogen, one more proton here, that will appear at 3.4. So here within the data 3.4, 5.62 hydrogens are there. So these are the vinylic protons, corresponds to 5.6. 2.67, which corresponds to these cyclopropenyl group. Carboxylic acid hydrogens are not provided within the problem. It is the partial spectral data analysis. And the next is about in either we will get 107, 146, 107 almost is equal to 105, 146, and 178 is there, this one. So based on this data, it is very clear that option number 3 will be the right answer. How can we get this one? Alkaline conditions ring opening got carried, ester correspondingly converted into dicarboxylic acid, right? So ester converted into dicarboxylic acid, it is very clear. Now what happens? It will participate in the ring cyclization reaction among these, and it in turn converted into a 3-membered ring structure with exocyclic double bond, and this will corresponds to the spectral data whichever provided within the problem. That's the reason why for question number 113, option number 3 will be the right answer. Now let us move on to question number 114. The reactive intermediate and the product formed in the following reaction. We are taking a double bond, ester, and what terminal iodo functional group is there. It will be treated with tributyl tin taken twice was given. So if any tin compound, alkyl tin compound was given, the reaction proceeded with free radical mechanism. And moreover, boron trifluoride diethyl ether upon photochemical conditions. Most of the photochemical conditions are proceeded with the concerted free radical mechanism itself. And moreover, here the catalyst will be tin catalyzed mechanisms, most probably free radical mechanism. They are asking for reactive intermediate. Obviously it will be free radical, and one more is what will be the product for this one. In order to get the product, we have to check the mechanism. Within the options, only first and second are having free radical mechanism. Carbon may not be possible, because in order to generate the carbon, either carbon trichloromethane, such a kind of moieties may be present, otherwise aza groups may be present. Any such groups when present, then only carbene will be originated. There is no provision for such a kind of reaction. Only the possibility will be free radical, and we have to get 4-iodo or 5-iodo. What is the position of iodo group, that we have to predict. Let us see the mechanism, and here is the reaction. So when we go with this kind of reaction with the N-butyl tin taken twice, this is a dimeric form. Here the double bond cleavage, here the cleavage is possible, and both get cyclized in this manner, so that you can achieve the compound, the final product with the 1, 2, 3, 4, 5, 6, 7, 8. 8-membered ring structure got generated with the lactone ring, and we got the iodo position. Let us count 1, 2, 3, 4, 5. At the 5th position, iodo group is there. 5th position iodo group is available only in the option number 2. So being it is a free radical mechanism, it will participate in the homolytic fusion of the bonds, and there is a formation of 8-membered ring with the iodo substitution at 5th group. That is given in the option number 2. For question number 114, option number 2 will be the right answer. And the next one will be question number 115. The major product formed in the following reaction sequence. We are taking OH, CH2, CH2, COH, CMe, CH2, C triple bond CH. So this is the starting material where we have esterenic triple bond, methyl, OH and OH. These many groups are present. And we are treating with the 4-methoxybenzaldehyde. 4-methoxybenzaldehyde will be added under protic solvent. DIBAL H being it is a reducing agent, reduction reaction got carried, and extremely low temperature, minus 78 to 40 degrees temperature employed on this reaction. Let us see how the reaction got carried. We are taking the starting material, and it is added with the 4-methoxybenzaldehyde. This is 4-methoxybenzaldehyde. When 4-methoxybenzaldehyde added, lone pair of electrons present in the oxygen will participate in the reaction with this aldehydic functional group. So this is the kind of reaction called a nucleophilic addition, so that oxygen will be added to this hydroxy functional group, and you will achieve one OH group on this. Now it will be added with DIBAL. The purpose of DIBAL is reduction. OH will be reduced into CH2, so that you will get the final compound, that is CH2 group. So that is available in the option number 1. So specifically, it will participate in the reaction with this OH functional group, whichever present at this position, right? So for question number 115, option number 1 is the correct answer. Now let us move on to question number 116. Again, it is the question from spectrochemical analysis of organic compounds. Organic compound having molecular formula C10H12O2 exhibit the following spectral data: IR 3400 and then second is about 1600. So broad spectrum is appeared for 3400. 3400 is a characteristic peak for hydroxy functional group, right? So and 1600 denotes what carbonyl group is present within the compound. Then HNMR data denotes 1.85 delta value for 3 hydrogens doublet, and the J value is provided as 6 hedges, 3.8 3 hydrogens, and the singlet will be appeared 5.0 1 hydrogen singlet deuterium exchangeable. Deuterium exchangeable hydrogen is there. That indicates what? Deuterium exchange possible only with the 2 functional groups. One is OH, second is NH2. So the given compound must contains either OH or NH2. In all 4 options, we have pre-OH functional group. Deuterium exchangeable hydrogens are there, right? So 6.01 hydrogen DQ, and J value is taken as 18. J value is 18 and 6 hedges will be given. 6.28 1 hydrogen doublet, J value is 18 hedges, and 6.75 peak will appear for 1 hydrogen doublet, J is equal to 8 hedges. 6.81 6.90 1 hydrogen doublet, J value is 8 ppm. And the C13 NMR 146.5 delta value, 144, 131, 130, 123, 119, 114, 108, 55, 18 ppm. So these are the spectral values in the C13. And the structure of the compound is, let us go with one by one. 3400 is the characteristic peak for hydroxy functional group. And 1600 is the peak for carbonylic functional group if amide group is there. So can you find any amide group in these compounds? No. Amide group is not at all present. So here you can discard with that. And one more characteristic peak at 1600 will be carbon-carbon double bond. If you have amide functional group will give peak at 1680. 1600 denotes carbon-carbon double bond. So carbon-carbon double bond is available in all 4 options. Even deuterium exchangeable hydrogens also present. This will not give the complete information, just a preliminary data you can collect from this letter. Let us move on to proton NMR. 1.853 hydrogens means what? Methyl. So let us see where methyl is there. Here methyl is there, here methyl, here also methyl, here also methyl. So this also no way useful. And next is about 3.83 hydrogens. 3.8 is the characteristic peak for methoxy. Whenever given compound contains methoxy, that peak will appear set at 3.8. Here methoxy, here methoxy, here methoxy, here methoxy, not there. So one of the option got discarded. Either 1, 2, 3. You may go with 1, 2, 3. Then 5 for 1 hydrogen deuterium exchangeable. That indicates OH. So OH first, second, third OH is there. Next 6 for 1 hydrogen. So 6 for 1 hydrogen is given. 6 for 1 hydrogen, where can you find that is the aromatic ratio? So and vinylic proton. 6 proton is vinylic proton. In first compound vinylic is there, second compound vinylic is there, fourth is not required, third compound also vinylic is there. So here also there is a ambiguity. And let us move on to further options. 6.28 aromatic, 6.75 aromatic, 6.8 aromatic, 6.9 aromatic. Sorry, 6.0, 6.28. These two belongs to what? Both belongs to vinylic protons only. Here vinylic proton is there, here vinylic proton is there. Both are correspond to 6.0 and 6.2. Now 6.75, 6.8, 6.9. This corresponds to what? This corresponds three set of aromatic protons are there. If you have only 2 set of aromatic protons, that indicates what? Para-substituted compound. But here protons are, aromatic protons are 6.75, 6.8, 6.9. 3 aromatic protons are there. Now let us see. In the first compound, 1, 2, 3 are different. This is a possible compound, may be possible. In the second, 1, 2, 3, this is also possible. In the third compound, 1, 2, 3, this may be possible. This is also not sufficient for us. So, let us move on to C13 data. Based on C13 only, it will be possible to predict what will be the structure of compound. C13 data denotes 18 belongs to methyl and 124, 130. 18 belongs to methyl, 124, 130. So these peaks are available, and that is available for this trans functional group. Cis may not be possible. This cis is not possible, only trans is possible, right? So those are available in the either option number 1 or 3. Now let us go with another spectral signals. 132, 111, 56. This 56 peak, let us see. 56. Yes, 56 peak is also there. So 56 peak is also there. Then 111, nothing but 114. So that corresponds to the benzene ring where this hydrogen gives rise to 114. So based on the spectral data, C13 is confirming this option number 1 is the correct answer. Because if here OH is there, you can't find that 111 peak. So here free hydrogen, free carbon is there, then only here 114 peak will be appeared for this one. So that here IR data, what it gave the information, primary information you got, 3400 denotes what C is there, 1600 denotes what carbon-carbon double bond is there, 1.85 gives methyl protons, 3.8 methoxy protons, 5.0 deuterium exchangeable hydroxy, 6.0, 6.2, these are the vinylic protons, and 6.75, 6.8, 6.9, this gives 3 set of aromatic protons are there. Later 146, 144, all these 146 data belongs to aromatic ring carbons. 131 is the vinylic carbon. Sorry, 130 is the vinylic carbon. 131 belongs to aromatic itself. And based on this, so this 114 you can identify the compound number 1 will be the right answer. 18 belongs to methyl. 55 belongs to methoxy. So based on all this data, for question number 116, option number 1 is the correct answer. Let us move on to question number 117. In the following reaction sequence, the reagents X and Y are respectively. So here we are taking a benzofused compound. Benzofused lactone was given, and here we have hydroxy functional group. It will be treated with a set of reagents of X. Now it will be turned into SO2 pH. When sulfur is there, that will become more antimicrobial, means antibacterial action will be very high for this compound. And this compound further treated with Y reagent, and it converted into another alkylated product. Let us see what are the suitable reagents required for this kind of transformation. For that purpose, we are taking benzofused lactone and treated with a phenyl alcohol, phenyl thioalcohol. You can say phenyl thioalcohol. So thiophenol, exact name will be thiophenol, because phenol nothing but benzene ring with OH. When benzene ring with SH is there, that is called thiophenol. When thiophenol is treated, what happens? OHH, water will be eliminated. Now it converted into thioether. This is called thioether, and it will be treated with metachloroperbenzoic acid. This will be the structure of metachloroperbenzoic acid. It is the specific reagent for oxidation. Metachloroperbenzoic acid is very essential for oxidation. So here sulfur converted into sulfur double bond O. So oxidation got carried on the sulfur center. Now we are going to add with a strong base called lithium diisopropylamide. This is the structure. Lithium diisopropylamide will be given. It used to pull the hydrogen from the center, so that here carbene will be generated. Now we are going to add alpha beta unsaturated ester compound. So when this alpha beta unsaturated ester was added, negative charge bounded to carbon. Pi bond is moving towards this carbon, so that you can achieve carbon-carbon a single bond. And you will get a negative charge on this carbon because of polarization of pi bond towards the carbon. Carbene will be originated. Subsequently, it will be treated with the protic solvent, so that here get protonated, and you will get the final product in this reaction. This is the final product what we are expecting. Let us see what are the series of reagents required for all these transformations. First, we have to add a thiophenol. Paratoluene sulfonic acid is working like a what we can say phase transfer catalyst. Phase transfer catalyst is required because here organic and inorganic both the moieties are present. In order to facilitate the reaction, to give the intimacy between organic and inorganic, we have to add phase transfer catalyst called paratoluene sulfamic acid. And metachloroperbenzoic acid, being it is an oxidizing agent used to convert thioether into sulfone moiety, and LDA will be the base and subsequently added with this alpha beta unsaturated ester, and you will get the final product. So series of reagents exactly matching with the option number 4. For question number 117, option number 4 will be the right answer. Let us move on to question number 118. The major product of the following reaction is, we are taking a cyclic lactone ring where the bromo, methyl, and another alkyl bromide is there. So what kind of thing? CH2, 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 Br group is there. So this is the entire moiety. What we are going to treat? We are going to treat with zinc acetic acid. Zinc acetic acid metal in the acidic medium used to facilitate the reduction process, especially when nitro group is there, that will be converted into amine. When we have bromo group, that will be eliminated and hydrogen will be added to the ring. So zinc acetic acid used to reduce this alkyl halide into alkane, so that here CHBr converted into CH2. Next, PHACNA will be added. So when PHACNA is added, Na plus Br minus will be eliminated, that converted into PHAC group added on this alkyl. Next step, metachloroperbenzoic acid will be added, being it is oxidizing agent that used to remove this entire group, and you will get a allylic group at this position, and it's subjected to heating. So we will finally achieve the substituted compound. Let us see what will be the series of reactions carried here. We are taking the starting material, zinc acetic acid, you reduce this bromo group, and here CH2 group got generated. Now it will be treated with PHACNA, NaBr will be discarded, and this phenyl selenium will be added at the center. Now metachloroperbenzoic acid, what it will do? It will oxidize the group, and upon heating, that oxidized group will be eliminated. You will get the allylic position here. That allyl substitution. So we are not going to change the stereochemistry of the compound. Just we are working on the terminal centers only, not in the core structure. That's the reason why here stereochemistry will not be altered. So here the stereochemistry exactly retained in the option number 1. For question number 118, option number 1 is the right answer. Let us move on to question number 119. The major product of the following reaction. We are taking a benzene ring, and tosyl group is there, and on this we have CH2, CH2, CH double bond CH2 called allyl. Allyl group is present in the nitrogen in the artho position having aldehyde. So you can say anthraldehyde compound with the allylic position, and tosyl is the protecting agent for amines, and it will be added with CH3, NH, CH2, COOH. It is a kind of secondary amine. Even you can say it is the system called what we can say alpha amino acid only, right? Not alpha amino acid exactly. So here COOH, if this nitrogen present on this carbon atom, you can say that is alpha amino acid. So up to this you can say it is a glycine. So glycine having methyl group on the nitrogen. So N-methyl glycine you can say, right? So here triethylamine, DMF, triethylamine is the base, dimethyl formamide is the solvent media. And upon heating, what will be the final product? We have to crack the mechanism. For that purpose, let us take the starting material, and this starting material will be treated with this secondary amine compound. Being nitrogen is a base, always one lone pair of electron will be present on the nitrogen atom. These lone pair of electrons will be attached to the carbonyl center, and the new carbon nitrogen bond is originated here, and that will give the positive charge here, and further the generated positive charge with the double bond And here trimethylamine used to abstract the hydrogen from this carboxylic acid moiety, and the corresponding carboxylate will be generated. Now it's subjected to heating. Upon heating, there is a rearrangement of the molecule by the removal of carbon dioxide as the byproduct. How can you remove the carbon dioxide? This negative charge will be migrated, and this bonded electrons will be shifted towards the carbon atom, which in turn form a cyclic ring with the terminal olefinic double bond, and this pi bond will be shifted. That will participate in the bond formation with this center, right? So because here olefinic double bond is there, that will be back polarized, and here the bond formation of this carbon with this olefinic carbon atom is possible. So there is a possibility of two cyclic ring formations. Two cyclic rings got generated within the structure. How it will be? So this carbon dioxide eliminated, you got eliminated, and here 1, 2, 3, 4, 5, 6-membered ring. One 6-membered ring is generated with the nitrogen heteroatom. You can say it is the saturated pyridine. Saturated pyridine is called piperidine. Now let us count the second one. 1, 2, 3, 4, 5. So another 5-membered ring also generated here. That 5-membered ring also having nitrogen with a methyl group in methyl. This is called a saturated pyrrole. Saturated pyrrolidine ring. Saturated pyrrole is called pyrrolidine. So it is a condensed system of 3 cyclic ring formations. Here is the nitrogen, here also nitrogen is there. This will be the final product what we are expecting in this reaction. That is available. So here tricyclic system, but it is not the correct one. Here you can find 1, 2, 3, 4, 5, 6, 7-membered ring. That is not at all stable. And only here 2 ring structures are there. This may not be possible. And here you got 3 ring structures, but there is a change in the stereochemistry. So here bridgehead carbon atom should be in the same retention. We are not supposed to change the position of hydrogens. Both are inclined towards the VR. This will be the suitable answer. So even though both are exactly resembling, only the change is a position of hydrogen. Stereochemistry of hydrogen is varied for option number 3 and 4. Only the requirement is to bridgehead hydrogens to be inclined towards the VR. This is a required final product, what we are expecting for question number 119. So this is kind of a chemical transformation. It is a part of organic chemistry. For question number 119, option number 4 is the right answer. Let us move on to last question of the series. That is question number 120. The major products A and B formed in the following reaction sequence are. We are taking alpha beta unsaturated carbonyl compound. Lithium diisopropylamide is added to this one in the presence of tetrahydrofuran, and another reagent called iodo CH2 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 chloro will be added. This is the kind of system called alkyl halide. So here you can find the trick in this. So being it is a tricky question, where you have to achieve the alkylation, because both ends it is added with the in both the ends you have halogens. Which halogen selectively treated with this one? So here it is the tricky bit is imbibed into this. Iodo and chloro both are there, and where you have to get the reaction. So after this you got the compound number A. It will be treated with the Grignard reagent methyl magnesium bromide in the presence of dry ether, and subsequently got hydrolyzed under acidic conditions, and you will get the final compound B. We have to see the series of reactions carried in this question number 120. Let us go with this alpha beta unsaturated compound is treated with LDA called lithium diisopropylamide dissolved in the tetrahydrofuran solvent. It will abstract the hydrogen. So here we have 2 provisions. Carbonyl group is an electron withdrawing. Around the carbonyl, here CH2 is there, here CH is there, where hydrogen is more familiar to remove. If you remove the hydrogen from the center, what happens? Carbene will be generated, that is called vinyl carbene. Vinyl carbene not at all stable because the carbene will be accumulated on that carbon because there is no provision for the resonance. So this option will be completely discarded. Only the provision for the generation of carbene will be for left hand side. Here the carbene will be generated based on its stability, right? After getting this carbene, now we are going to treat with this important alkyl halide. In the both ends you can find the halofunctional group. One end is added with iodo, in either end you have functional groups, right? So but here we have to go with the reactivity. So iodo being it is a larger one, So here it will be strongly attached to this atom, so that here alkylation is more facilitated with this rather than chlorofunctional group. Chloro remains as such, so that we got CH2, 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 Cl attached at the alpha position. Now further we are going to treat with the Grignard reagent called methyl magnesium bromide dissolved in the dry ether. So magnesium bromide, methyl will be the negatively charged and magnesium will be the positively charged one. So here that will be attached to the polar carbonyl functional group. How it will be? When pi bond is shifted towards oxygen atom, oxygen acquires negative, carbon positive. Then methyl selectively attached to the carbon because positive charge will be added with the negative. So here methyl on the carbon, you got it. Then O minus will be added with magnesium bromide. Here there is a formation of OMgBr. Now we are going to subject hydrolysis. Hydrolysis used to cleave the bond. This ether will be retained by the magnesium, subsequently turned into MgBrOH. Now here OH will be added to the carbonate, so that it turned into OH functional group. OH group got generated at this position, right? After getting this, what we are going to do, this double bond is shifted towards this side. This double bond is shifted towards this side. Subsequently OH group is eliminated, and here the double bond formation is formed. So final product will be with the double bond in between this carbon and carbon containing this methyl functional group, so that we will get the final product. That is available only in the option number B. Here you can find a double bond, where double bond is their alpha beta unsaturated compound, and that in turn converted into, just a second. Right. So in this mechanism, just now we saw LDA used to originate the negative charge called the carbene ion, and in turn treated with alkyl halide iodo, being it is more facile to attach with this carbon center, so that alkylation carried in this end only, and subsequently added with the methyl magnesium bromide dissolved in the ether, so that here Grignard reaction got carried and methyl group added to the carbon. And next step, water will be added and oxygen carbon bond will be cleaved, and we got hydroxy. And here you can find oxygen containing lone pair of electron will participate in the double bond formation, simultaneous shifting of bond in this manner, and subsequently OH group is eliminated. Here you can find a removal of OH group, and here the formation of double bond, and here the new double bond got generated. This is simply alpha beta unsaturated compound again. So initially alpha beta unsaturated compound is there in this direction. Through the set of reactions, you got alpha beta unsaturated compound in the reverse manner. That's why we can say it is very tricky question. So here question number 120, option number 3 will be the correct answer, where you got alpha beta unsaturated at a meta position with respect to this methyl. So A will be a alpha beta unsaturated ketone that is added with the alkyl functional group at the third at the alpha center. Treating with methyl magnesium bromide followed by hydrolysis, you will get the alpha beta unsaturated compound number B. So for question option number 3 is the answer. By this entire series of CSR NET GRF chemical science December 2014 part C series 5 was completed. This session will be helpful for your preparation. Thank you very much for your consistent listening. Thank you one and all.